This is 4.6. How can you use operations to combine functions that model real-world situations? So we're looking to combine functions. Here's how it looks. I'd give you a function. 3x minus 1 is equal to f of x. G of x is equal to negative 2x plus 2. And then I might say combine these two functions. And I want you to add them. And that'll make a new function, h of x. So all you do is you take the operation I'm asking you to do and write in what the function rules are. So for f of x, it's 3x minus 1. For g of x, it's negative 2x plus 2. And now what we need to do is just add them. So you can remove the parentheses. And we use the commutative property to move the negative 2x up by the 3x, move the negative 1 over by the 2. After that, we use the associative property, and we say h of x equals, combine your like terms with associative, x plus 1. And that's your new function with the function rule of those two being added. Or not the function rule, the operation of those two being added. So now we might have a different function rule. We might say f of x is x plus 5, g of x is 4x minus 2. We want to subtract these two functions. Again, you write the operation with the functions that I'm asking for, and then you simply plug in f of x is x plus 5, so plug in x plus 5 for f of x. G of x is 4x minus 2, so you plug in 4x minus 2. Now this one just drops down. It doesn't need to have anything done. You can just remove the parentheses. There's nothing in front of it. On this one, there is a negative in front, so we need to distribute it to each of these. Negative times a positive is negative. Negative times a negative is positive. Now we use the commutative property and bring our x terms together. So we have x minus 4x plus 5 plus 2. Combining these two, x minus 4x, negative 3x. 5 plus 2 plus 7. Okay? And that is your next term. Or that is what the function rule equals. Okay? Next, we might end up with a function rule where I ask you to multiply the two functions. So you take the f of x, the g of x, and show that you're going to multiply them. Then plug in the f of x, which is 3, and just plug straight in the parentheses. Setting the 3 right next to it means multiply. As you get rid of that, you would simply distribute that 3 to each of those. 3 times a third, or a third of 3, is 1x. 3 times negative 2 is negative 6. So we get h of x equals 1x minus 6. Now we have some real-world situations that can use this. Okay? We have a number of girls that sign up for soccer camp every year. The first year soccer camp began, there were 44 girls. And then what we've noticed is each year there's 5 more girls. So we would write our equation. You know that it started at 44 plus 5 at each year. And I see that t is my independent variable from this. So I just plug in t. T means number of years. Now on the bt equation here, get my brown pen going for this one. The number of boys at camp was 56 the first year, and 8 more each year, so 8t. Now what I want to know is the total for the 2 years. So all I need to do is plug in my amount for the girls, for the GT, 44 plus 5t, and the amount for the boys plus 56 plus 8t. And that all will equal my total. Now, our next step would be commutative property to put the 5t and the 8t together. I would expect you to write it 5t plus 8t plus 44 plus 56. And then you simplify by using associative property. 5t plus 8t would be 13t. 44 plus 56 will be 100. So there's the total number of kids coming to my camp over the years. That's what I can expect to have at the camp. The cost per child is $200 for the camp. So if I want to write a function of that, the cost per child, 200, so that's just a constant. That isn't changing. $200 per kid. Total enrollment from this other board, what I just wrote, is 13t plus 100. That's the total number of kids that come. Now, if I want to know my total revenue, I would take the price per kid times the number of kids. The CT times TT. 200 for the cost, 3t plus 100 for the number of kids. So to find out my total revenue so that I can plan my camp staff and what activities, what I can afford, 200 times 13t. I just take 2 times 13 is 26. Add the 2 zeros. 200 times 100 would be 2, and then add all 4 zeros. So I've got $20,000 plus $2,600 per year that I seem to be gaining. So if it's 10 years since I started this camp, then I know I'm going to have about $26,000 plus the $20,000 that I started with that first year. So that's the total revenue. Okay, see you in class.